Question 57. PQRS is a parallelogram such that line PQ is 15 centimeters, line QR is 18 centimeters, and angle PQR is 30 degrees. Determine the area of the parallelogram. You should know what a parallelogram is. A parallelogram is a shape where the opposite sides, same lengths, are parallel to one another. Let's just draw. It's best we do our drawing from the angle where you have PQR. That's Q in the middle. That's Q is where you have the angle. Then the Q to line P, then Q to line R. Let's just draw. Let's have our first line like this. Then you have another line like this. Don't mind that the line is not straight. It's supposed to be a straight line. Then your angle is here. That's 30 degrees. This is your Q. We can make this to P and this to R. Because it's Q in the middle. This is line QP and line QR. You should learn this thing very well. We have QPR. Then we're left with S. And QR should be parallel to PS. So we make PS a parallel line to line QR. As PS as the same length and they are parallel to one another. Then you join RS or SR. This is 30 degrees. From the question, we've been told that PQ is 15. That's PQ is 15 centimeters. This is 15 centimeters. And QR is 18 centimeters. This is 18 centimeters. And if this is 18, this is also 18 centimeters. And if this is 15, that's QP is 15, RS or SR is 15 centimeters. Question says determine the area of the parallelogram. Formula for the area of a parallelogram is base times height. We know our base is 18, but we don't have our height. That's the vertical height. And for us to get the vertical height, from this point P, we draw a straight line down, makes an angle 90 with line QR. That's this straight line. That gives us the height. From P down to the point where our dotted line hits the line QR to Q and back to P is a right angle triangle. With this right angle triangle, we can get our height. And once we know our height, we can then apply the formula to find the area of the parallelogram. For the sake of understanding, let's redraw. So we have it like this. And this is a 90 degrees. And this is our Q. This extends to our R. We don't need it for now. We have our P. And we have this as 30 degrees. And here we have 15 centimeters. And we need this side, which is our height. Now looking at this is a right angle triangle. Therefore, we apply Pythagoras theorem. This side facing the 90 degrees is the hypotenuse. That's, in this case, 15 is our hypotenuse. The side facing the acute angle, that's angle less than 90 given to us, which is 30, is H, which is the opposite. So H is our opposite. With the hypotenuse and the angle, we can find the opposite. We know the Pythagoras theorem that applies in this case is sine theta. Sine theta equals opposite over hypotenuse. We have it as sine 30 equals our opposite here is unknown, which is our H, which is H over our hypotenuse, which is 15. I can write 15. Since we're having a fraction and multiplying, we can make this sine 30 over 1, then we cross multiply. We start with H times 1 or 1 times H. So you have H times 1 equals, then on the other side we have 15 times sine 30. 15 times sine 30. H times 1 is H equals 15 times sine 30 is 0.5. That's 15 times 0.5. H equals 15 times 0.5 is 7.5. So we have our height as 7.5. Going back to the initial diagram of the parallelogram, so we know our height is 7.5, and with our height and our base, which is 18 centimeters, we can find the area of the parallelogram. So area of the parallelogram equals our base is 18 and our height is 7.5. 18 times 7.5 will give you 135 centimeters square. Therefore, the answer to question 57 is B. That's 135 centimeters square. A recap of question 57 is that we have to draw the parallelogram, and since we have the base and we don't have the height, draw a line from point P straight down to make an angle 90 with line QR, So we can have a right angle triangle, and using the angle and line QP, we found the height using Pythagoras theorem, and with the height and the base, we're able to determine the area of the parallelogram.